You already know how to solve two basic types of equations. Linear equations, even including fractions, like this, and quadratic equations, like this. Quadratic equations offer you a choice of 4 different ways to solve them. You've seen all 4, but if you need to review any of them, don't worry, there's a whole module on each one. In this module, we're going to look at some other problems that can be solved in a similar way. They don't look like quadratic equations, but they are, in a strange sort of way. Here's one to try. That x to the 6th makes this a degree 6 equation, so it's certainly not quadratic. But it should remind you of some of our practice problems in factoring. You might just spot how to factor what we've written here. Or you might substitute a single letter for x to the 3rd. Let's try u right now. So u squared is x to the 6th. We rewrite our equation using u, and suddenly find that we have a quadratic equation. So we can factor, and then put back our x to the 3rd. It was equal to u, remember. And suddenly we have exactly the same factors we spotted earlier. We continue as if we were solving a quadratic equation by factoring. Each bracket may be 0. At least one of them has to be. Then one final step. We take cube roots to get x on its own, and that gives us 2 real number answers to our equation. You might have been expecting more answers, since it is a 6th degree equation after all, but we've found the only real number answers. We could find extra complex number solutions by factoring like this and using the quadratic formula, but let's stick with the real solutions for now. Just notice how our method copied the process for factoring a quadratic equation. Now here's a similar one for you to work out on your own. Be sure you do a substitution first to get a quadratic equation, and then factor. This time I have an x to the 4th, so I want to use x squared as my substitution. X squared is u, so x to the 4th is u squared. Now I'm ready with my rewritten equation, which I find I can easily factor into 2 brackets. I remember, of course, that u equals x squared. And that gives me 4 real number answers. Now here's a different looking problem. Rather frightening, actually, but it's done exactly the same way. First, we find a substitution that will change it into a quadratic. And here's the key. We let u equal x to the 1/5 power, and then u squared is x to the 2/5 power. So again, we can rewrite the equation in quadratic form, ready to factor. And from there on, there's not much to it. It's a little harder to factor, but we can handle it and get a couple of fractional answers. If you get one that's just too hard or doesn't factor, then you can always use the quadratic formula to get the values for u. That's what the formula is for. But in this case, let's just finish off our substitution and get our answers for x. They're pretty weird numbers, but that's okay, because they're the right weird numbers. You'll find more problems of the same type in your book. Try some of them right away before you forget what this is all about. Now, ready for something else. Here's a very different type of equation that can also be changed to a quadratic type. Equations with square roots in them. How are we going to get rid of the root? Of course, square it. So we have to square both sides like this. And if we can look past appearances here, we'll see that with a little rearranging, it's a quadratic equation. Once it's rewritten in the familiar form, we can solve it. The question, which method will we use? Well, it doesn't seem to factor, so let's try the quadratic formula. Do the substitutions for A, B, and C, and then simplify. This gives 2 solutions like this. But unfortunately, we need to check our 2 solutions by substituting. We haven't done that for a long time. The problem practically screams for a calculator, so we give in and find that one of our 2 answers works and the other one doesn't. How did that happen? Well, it's in the nature of certain kinds of square root problems. They give us an extra answer that's wrong and perfectly useless. Here's how it goes. We start with an easy equation. Square both sides. That's the key step. Then, when we solve it by undoing the squares, lo and behold, we get an extra answer that we didn't even ask for. That's a problem, and that's why we have to check our answers by substituting. Anything else we've done to both sides of an equation, fine. The solutions remain unchanged. But the minute we square both sides, look out. We may have produced an extra answer we don't want, as well as the right one, of course. Square roots do add a little spice to the process, so let's take a look at another one. We could just leave it as is and square both sides, but it's easier if we get the root on its own first, and then square. Why don't you take it from there and finish it off? Be sure to check your answers by substitution, and then come back. The first thing I want to do is square both sides and then do some rearranging. I use FOIL, of course, for the multiplication, and I end up with some big numbers. But after a few tries, I find I can factor it. Or I could give up and use the quadratic formula. It'll work, too. And either way, I get two numbers as possible answers. Fortunately, this time they're easy to check by hand like this. And once again, we only get one answer that works. Y equals 18. Now you'll want to do some more of this kind of problem. You'll find more in your textbook. And you'll find that in some of them there are two separate square roots. In solving that kind of problem, you'll have to square twice. Notice that that step appears here twice, as number 1 and number 3. Aside from that, it just takes a little practice. Good luck.